what you're doing. Okay, so this is just a factoring review worksheet. There is factoring on many of the topics from here on out in chapter 2. What would we need to do on number 1? I'm just going to go through the circled ones, and several of them say next to it, it's like number something that's also on here. What would we need to do on this first one? Anybody remember the factoring flow chart? What do you do when there's 4 terms? Yeah, we need to do grouping. What can we do to the, if we just leave it in the order it is, what could I take out of the first 2? Okay, an x squared. So if I take an x squared out of those 2, I'll have an x plus 4. Now, the parenthesis has to be the same for the second one, or this doesn't work. -1. Okay, take out a -1. Very good. Now, it says you don't need to solve, even though they say equals 0 up here, okay? So I'm just going to ignore that. So now, if I take the x plus 4 out of each of those, left is an x squared minus 1. Is that factored completely? Guys, what's x squared minus 1 factor to be? X minus 1 and x plus 1. It is the difference of perfect squares, right? So here are the 3 factors that would help us find the 3 zeros. All right. Do I have one like number 2 somewhere? Oh, number 3. Okay, when you have an x to the 4th and an x squared as your only powers of x, anybody have any ideas what we could do? We could get an x to the 4th by multiplying an x by an x to the 3rd, or an x to the 4th by a constant, but we could also get it by multiplying an x squared times an x squared, because you'd add the exponents. Does that make sense, guys? All right, and since this middle term is also an x squared, I think we're in good shape to do this. Now, what factors of 18 would give us a 7? Okay, so we try a 9 and a 2. Now, it's a -7 and a -18, so I'm thinking -9 and +2. How's that looking? All right. That, if we FOIL that back together, we would get, okay, we would get this. So that part's good. Yes, but as Martin says, what happens to the x squared minus 9? Yep, x plus 3 and x minus 3. Can x squared plus 2 go further? No. Only the difference of squares can, and 2 isn't a perfect square anyway. All right. Number 3 says it's like number 6. All right, this has an x to the 6th and an x cubed. Any ideas on how to start? Kind of like we did this last one. How did we make an x to the 4th? X squared and x squared? What can we do here? X cubed and x cubed. Factors of 125 that would make 124. 125 and 1. Okay, -125 and +1. Does that work if I FOIL it back together? I would get an x to the 6th minus 125x cubed plus 1x cubed minus 125, which would work, right? Okay, you are absolutely right. We need to break both of these down. Does anybody remember how that pattern goes? A cubed plus or minus b cubed becomes AB and then a squared with an AB and a b squared at the back, and this one's always plus, but this goes plus or depends what it is, right? It's actually, if it's plus here, it's minus here, and then a plus on the bottom. All right, but that's kind of the pattern. So this is x minus 5, very good. But then what's the second parenthesis? Well, it's how you factor this.
It's going to be 25.
X squared and 25 at the back, but not in the middle. It's 5x in the middle. And the first one is plus, and the second one is always positive. Now, some of you don't believe that, so I'm going to go real fast. Look, if I distribute through there, and Martin, are you watching? If I distribute the x through there, I get all this mess. If I distribute the negative 5 through there, I get this. Do you see what happens? This, and this, this, and this, and I left with x cubed minus 125. Okay, that's how this factors. It does not factor x minus 5 quantity to the third. Some of you are still putting that on stuff. Okay. The second one also factors. Anybody know that one? X plus 1. I don't know if I can move all these over. I didn't leave myself enough room here. Oh, lovely. What have I done? Woo! They're dancing. Oh my goodness. What did I do now? Yeah, I would just erase and be good, but it was going crazy there. Okay. So this one was x squared plus 5x plus 25. And then we're on this, I'll use a different color. We're on this one. So that one is x plus 1, and then x squared and a 1x and a 1. What are the signs? Minus and plus. Lovely. Isn't that lovely? Aren't you glad we don't have to solve? Does anybody remember what you'd have to do to solve those two? They don't factor further. Why? Quadratic formula, yes, yes, yes. You have to do quadratic formula twice to solve that problem. Ugh. Okay. That's it. Nope, number 7. Just kidding. What can we do first on number 7? Take an x out. So then we'll have x to the 4th plus 5x squared minus 6. Anybody figure out how that's going to factor? When you only have an x to the 4th and then x squared, do you remember what we did? Yeah, x squared and x squared. Now we need to multiply to make negative 6, but add up to 5. Okay, 6 and 1, as long as it's a negative. So this is plus 6 and minus 1. Are we done? Which one goes further? This last one. All right. So that yellow sheet is on the homework check. Okay? You need to factor. The back side may just have the answers. Okay? So you just need to finish the front side. On the back side, are they actually solved, though? Does it even have the factors? Oh, it does have the factors. Okay. Yeah. So check yourself on the back, but don't just copy, guys. You got to know how to do this stuff. All right. The other thing we're doing today is starting lesson 2.2. We're going to spend about 2.5 days on this lesson, but today we're going to get through most of these concepts. Okay, I can determine the end behavior based on the degree and leading coefficient, determine the possible number of zeros and turning points, and I know the difference between even and odd functions and even and odd degree. And I can identify the multiplicity of zeros. These are all pretty basic concepts. All right, I already talked about this, but I put 1.7 and 2.1 on the next quiz. Okay, If you did poorly on transformations or 1.6, you need to come in on your own time. I'm skipping those today because we just practiced factoring. All right. In lesson 2.1, we learned basic characteristics of monomial functions. Remember, everything we did just had one term, and it was on section 2.1 quiz. Remember, like one quiz had something with a negative, I don't remember what the other one had. One graphed like this, right? And the other quiz version had like that or something, but it was a monomial term. Today we're going to talk about polynomial functions, meaning they have many terms, okay? A polynomial function is anything that can be written in this form where all of the leading coefficients just have to be real numbers. They can be anything, okay? N, the degree, the exponent powers have to be non-negative integers. What does that mean? This would not count as a polynomial function, okay? Because it's got a negative up there. And this would not count as a polynomial function because it's got a fraction up there. Okay, polynomial functions have to have positive exponents that are basically whole numbers. Okay. What is the degree of a polynomial mean? In my brain, it just means the highest exponent power. Does that make sense, guys? The degree is the highest exponent power anywhere in the problem. And the leading coefficient is whatever the big number out in front of that is. Does that sound familiar now? So, polynomial functions, by the way, by graphing, we have these three that we've done so far: constant, linear, and quadratic. We've done a lot more than that, but those are three of them. A polynomial function, when you graph it, has to be continuous, which was not the case for the ones we did on 2.1. These are not polynomial functions. All right, so recall that graphs of even degree, non-constant monomial functions resemble the graph of x squared. And if it's odd degree, it remembers remember we talked about this, that if it's an x to the fourth or an x to the sixth, it's all the same shape as long as it was a monomial term, right? And these were also all the same shape as long as it was one term. All right, these were all going this way unless they had a negative, in which case they flipped and went this way. These were all going this way unless they had a negative, in which case they went this way. But today we're going to talk about things that are not a single term. Oh, first we're going to talk about transformations. This is a degree 5, so it should look like that. But what does that do to it, guys, real quick? Right to... What would this one do? Two things going on here. An x to the fourth should look like this, but a negative made it go down, and then the plus 1 moved it up 1, in that order, by the way. Flipped it and then moved it up 1. So an x cubed looks like this, but what two things have happened here? The negative means it's going to be this shape, and it's really like this, so this plus 4 means what? It's up here at 4. What's this one doing? Is that a 4? Okay, degree 4 means it's that shape, and this one is shifted, yep, over here to -7. All right, way back in lesson 1.3, we talked about end behavior. You are going to be able to predict end behavior now using what's called the leading term test. All right, the leading term test uses the power and coefficient to determine the end behavior. This watch out box just says be really careful, because if a polynomial function is not written correctly in the correct descending order, What is the degree of this polynomial, guys? Yeah, it's degree 4, even though the leading coefficient is way back here, right? So this is degree 4 with a leading coefficient of 7. Everybody good? The degree and leading coefficient always come from the same term. If I rewrote that in standard form, it would have said 7x to the 4th minus x cubed plus x squared plus 2. And then it would have had the leading coefficient out front where it seems like it should belong. All right. We're going to take notes on a little chart on this real quick in a second, but I want you to think about this. When the degree is n, okay, so if the degree is odd, so it's a degree 3 or degree 5, okay, then it will have this up and down shape so that the ends are going opposite directions. Everybody good? All right, if it's positive, like an x cubed, it could have some stuff going on in the middle, but the left end will always be down. If it has a negative out front, the left end will be up. And then what they're trying to show you is that we can have some gobbledygook going on in the middle now. Even, again, positive, even degree, both ends will go up, just like a parabola. Even with a negative leading coefficient, both ends will go down. So on our little chart, on your notes, even degree, positive leading coefficient would be like an x to the 4th, 2x to the 4th, minus 3x squared plus 7x plus 5. Ooh, that's a disaster, okay? But the shape will be both ends up. Even degree, negative leading coefficient, all right, might be as simple as 7 minus x squared minus 9x to the 4th. Now, this one has the degree and leading coefficient back here, but the end value would be that both ends are going to go down. It might be doing some loop-de-loops in the middle, okay? But both ends are going to go down. We are relating end behavior only at this point. All right, odd degree, positive leading coefficient. What's the left side doing, guys? Okay, so this is a degree 3 with a leading coefficient of positive 2. What should the left end be doing? Down. We don't know what's going on in the middle, but the left end should be going down. Okay? A negative leading coefficient might have just a negative x to the 5th plus x to the 4th minus 2x squared plus 9. I have no idea. But when you have a negative out front and it's an odd degree, the left end will go up. Okay, I don't know what these are doing in the middle. I'm just looking at the end behavior. Everybody okay? All right, what is the difference between an odd degree and an odd function? Martin? Okay. This is about symmetry, and it's not. It's actually odd is origin symmetry, and even is y-axis symmetry. Why is it not x-axis symmetry? If something had symmetry about the x-axis, would it be a function at all? No. Okay, so it's not a function if it's got x-axis symmetry. Even in a degree, though, is the highest exponent power, right? And what does it determine? It determines, along with the leading coefficient, it determines end behavior. It also determines the number of turning points and zeros and all kinds of stuff, okay? But even degree means both ends go the same direction, either this or this. Odd degree means they are going opposite directions. The end behaviors are going opposite directions, okay? And this has to do with end behavior, as Destiny said. All right. So this question just says, take a look at this mess. What is the degree, guys? Degree 4, leading coefficient. So it's even, meaning both ends go the same way. The leading coefficient is 2, which is positive. So both ends are going up. Okay. It's not a very good window because it looks like it's going vertically if we stretched it out. Oh, do I have one off the side here that oh, no, not really. Okay, moving on. So tell me, isn't this the same question we just did? Pretty much. This would be both ends going up, yes? Okay. How do you write both ends going up? F of x, some of you are still struggling with this. This is y, right? So I want to say up and up, yes? Both the y's are going up. As x approaches negative infinity means on the left, and positive infinity means on the right. Okay, here's an example. Why does it say be careful? It's not in order. So what is the degree? Leading coefficient is, okay, so it's odd degree, meaning the ends are going to go opposite ways, right? If you can picture a cubic, which goes that way, this one has a negative coefficient, so this one's going to go the opposite way, yes? This is the cubic shape. When we do the negative leading coefficient, it flips it, so it's going to go this way. In the middle, it could be doing a bunch of junk, I don't know. But I do know that the left end goes up. How do I write that? F of x goes up, positive, as x goes to the left. And it goes down as x goes to the right. All right. These are all what are called quartic functions, which means degree 4. No, they're not. What does that say? Consider the shapes of following third degree polynomials or cubic functions and fourth degree or quartic functions. Okay, these two are quartic because both ends are going the same way, and these two are cubic. All right, observe the number of x-intercepts for each graph. This one has how many? 3, but it's also possible that a cubic can have only 1. Degree 4 can have 2 or 4. It could even have 3 if that middle loop had just barely touched like that. Could it have 3 places that it, okay? Maximums and minimums are called extrema or extrema. I've heard it pronounced both ways. And the graph has a turning point when we have an extrema, okay? The number of turning points is where the graph changes from increasing to decreasing, and they are called maximum and minimums. So this could be a degree 3, but it could also be higher, but it would have to be an odd degree. But it could cross x 3 different places. This one has how many turning points, guys? 1, 2, 3, 4. okay? This one was probably degree 3, and it had 2 turning points. Do you see the relationship here? Okay, this is like a degree 5, because the ends are going opposite directions, and it has 4 turning points. Okay, how many turning points on this one?
3.
Yes,
So,
and it's probably a degree 4, because both ends are going down. It could actually be degree 6 or 8, but the rule is a function of degree n has at most n minus 1 turning points. So down here, put this in your notes. It says, is there a place for you to write this or not? If the degree is n, that is the maximum possible number of zeros is n. But the degree minus 1 or n minus 1 will tell you the maximum possible number of turning points. Okay? The degree equals the maximum number of zeros possible, and the degree minus 1 is equal to the maximum number of turning points. And what are turning points again? Maxes or minimum. Max or min. Everybody got that somewhere? I think I forgot to put a blank for it, and that's why I just said put it in your notes somewhere. All right. So that was called, that's just a key concept, I guess it wasn't a theorem. Okay, so more vocabulary real quick. When we say x-intercept, your calculator calls it the 0, right? Okay, so those are 2 things. It is also, if you have an equation that's equal to 0, you can say it is a solution to the equation. And when we factor things, we say x minus c is a factor. So we have to remember how all of those things are related. All right, so this is an example that you have, I think. It says state the number of possible and real zeros. Okay, what degree is this, guys? Degree 3, so the maximum number of zeros would be 3. What would the maximum number of turning points be? 2. Then determine all the real zeros by factoring. Okay, this was a factor by grouping. They took out an x squared out of the first 2, and then they wound up with x squared minus 1 times x plus 2. X squared minus 1 was difference of squares, so it factored x plus 1, x minus 1. So they found all 3 real zeros by simply factoring. And the graph would have 2 turning points. Any questions? So let's practice. Degree of this one. This is degree 4. Do you have this question? Okay. It's on the back. Okay, degree 4. So the maximum possible number of real zeros is 4. And the possible number of turning points would be 3. Doesn't mean it necessarily has that many. Graphing it might prove otherwise. But that is what I'm expecting you to answer based on the degree and leading degree, just the degree, I guess, okay. The leading coefficient here is positive, so both ends would go up if it asked about end behavior. How are we going to factor that? We just practiced this today. X squared and x squared minus 3 and minus 6. Will that make a negative 9 in the middle? Okay. Any of those factor further? No, but can we set them each equal to 0 and still solve for real numbers? X squared minus 3 equals 0 means x squared equals 3. So we get x equals what? Square root of 3 or negative square root of 3, which you could have written plus or minus square root of 3. And this one, x squared minus 6 equals 0, x squared equals 6, x equals plus or minus the square root of 6. So how many solutions did we end up with? Yes, square root of 3, negative square root of 3, square root of 6, and negative square root of 6. That one has 4 real zeros. They're not nice, right? But they're real. It would cross the x-axis at 4 places. Okay, B, anybody? Degree? Okay, so the possible number of real zeros, maximum would be 5, turning points would be 4. Okay, what can we factor first? Take out an x, that leaves x to the 4th minus 6x squared minus 16. Okay, now when we have an x to the 4th and an x squared and nothing else, we can divide it x squared and x squared into 2 parentheses here. Factors of 16, that'll make 6, 8, and 2. We need a negative 6, so I'm thinking a negative 8 and a positive 2, yes? Okay. Now, where are the real zeros? This one, if we just said x equal to 0, is a 0. X squared equals 8 would make x equal to what? Which is 4 times 2. This guy gets out of jail, so we get 2 square roots of 2. Everybody okay with that one? But what happens here? If I set x squared plus 2 equal to 0, I get x squared equals negative 2. If I go to square root, what do I need? Imaginary numbers, right? So it wants real zeros. So are these real? Nope, we don't have to worry about them because it says that has no real solutions. So we found 3. And I don't care if you don't write them out separately on a quiz, okay? It's fine with me if you don't. But I'm just trying to point out to you that we found 3 places this would cross the x-axis. All right, this one says to graph it and describe the end behavior. Can we describe the end behavior before we go to the graph? What's the degree? Leading coefficient? Negative 3. So odd degree means the ends are going opposite ways. What does a negative leading coefficient mean? The left is actually going where? Up? Now, the reason this is important, even though you have a graphing calculator in your hand, your graphing calculator can be misleading. I don't think it's going to be misleading on this particular question, but your calculator can be very misleading depending on your window. It could look like a parabola because some of the graph is off the side when it's supposed to be a degree 5 or something. What was this one, guys?
Negative 3x 5 plus 2x.
3x to the 5th. I'm sorry, then what? Plus 2x squared minus 1. Thank you. If I do a zoom 6, I get this. How many real zeros? But does it appear that we're seeing all the end? It can't be going up and down further on. It can't be coming back down somewhere to the left or the right, right? This is the correct end behavior. So what did it look like? I'm just going to cheat. So there's what it looked like. All right. Oh, describe the end behavior. Okay. What is f of x doing? What do you want me to write? It's going up. So what do I write? X approaches, okay? And then f of x is approaching negative infinity as x approaches infinity. So this was up on the left, down on the right. Make sure you get end behavior by now. And we explained our reasoning with the degree and leading coefficient. All right. I'm going to skip this one for right now. All right, we're going to talk about repeated zeros and whether the graph crosses, kisses, touches. Some of you should remember this from last year, but when you have a repeated zero, so if I had this, okay, this is a degree 4. Does everybody get that? Because this one has an exponent of 2. So my example right here would be degree 4, but it would have a 0 at -2, a 0 at 3, and this 2 up here is called multiplicity 2. Means it's a repeated 0 twice, and then it would have a 0 at 1. The repeated 0, if it is of even degree, means the graph bounces off the x-axis or just touches it or kisses it. Different teachers use different vocabulary. So this, if I graphed it, was a degree 4, so it would have come -2, +2, and 1. It would have come from here, crossed at -2, crossed at 1, but then at 3 out here, it would have done a bounce like that. All right, so do you have this little chart in your notes or something? Okay, multiplicity is m. It's the exponent power up here, okay? If it has an odd multiplicity, it crosses. If it has an even multiplicity, then it touches or is just tangent to the graph. A zero that does not repeat can be thought of as an odd multiplicity. So, multiplicity. This one is the only one that has a multiplicity other than 1. This is a multiplicity 3. Okay, so what are the zeros? Is -2 a 0? No. -2x would equal 0 when x was 0. The -2 is really just a stretch. So 0 is one of the zeros. This guy right here, x minus 4, would mean x equals 4. And 3x minus 1 would equal 0 when x equals what? 1/3. Now, which one of those is repeated? Only the 1/3, and it has a multiplicity of 3. Now, what is the total degree of this polynomial? This was there once, and 3 times. Once, and 3. So what is that total degree? Degree 5, which had a leading coefficient that was negative. So it should have this shape, okay? What did they tell us to do? Determine the zeros and state the multiplicity, find a few additional points, then graph. We're not going to have time to find a few additional points and graph, but this is how Hofbauer had to learn to graph, guys, because I didn't have a graphing calculator. Okay, this one crosses at 0, it crosses at 4, and at 1/3. It also has a 0. It's going to come from the top. Are any of those going to be bounces, guys? This odd multiplicity still means it crosses, right? So it would cross here and actually do a little loop-de-loop, and then it would come over here and cross here. All right, I'm going to try to get through this last one right here. What can I take out of all those? Even it'd be nicer if we took out a -x, I think. That would leave x squared minus 2x minus 8. which would then factor x minus 4 and x plus 2. Okay, the whole thing was degree 3 with a leading coefficient of -1. So it should be doing this shape again. But the zeros are where? 0, 4, and -2. Any of those repeat? No, so it should cross at all those places. -2, 0, and out here at +4. So it should be crossing, crossing, crossing. Now, what I had to do when I was in school was find something between -2 and 0 and figure out how far down that one went. And something between 0 and 4 and try to figure out how far up that one went. You guys have a graphing calculator. Make sense? Okay, so at least get the factoring worksheet done tonight. This is the book work, and it is in Google Classroom. Those are the problems assigned tonight about degree and leading coefficient and end behavior. Okay, all we missed was one question. This one would have had x equals 0, x equals -5/2, and x equals 3. This would have been multiplicity 1, multiplicity 2, and multiplicity 1. And it's negative, so it's degree 4. So both ends are going down. I am after school today. So this one would have crossed. Oh no, that's where it bounced. My bad.
Have a good day.
Thanks, you too. This one would have bounced here and then crossed so that it had both ends down. All right, you too. So we finished this lesson. You should be able to do all those.